Hello everyone, I'm Zihan, a fourth-year PhD student from University of Michigan School of Information. Today I'm presenting our work, SQL Puzzles, Evaluating Micro-Parsons Problems with Different Type of Feedback as Practice for Novice Programmers. This work is by myself and my advisor, Barbara Ericson. To start with, I will give a brief background on what is SQL and what is micro-Parsons problems if you are not very familiar with the specific context of teaching programming. Relational databases are very commonly used in production to store all kinds of records and data. Managing those databases with structured query language, or SQL, or sometimes called SQL, is an important skill for students in the field of computer science, software engineering, and information systems. However, they can be confusing for beginners. They contain a number of keywords and use very specific structures to explain the operations that need to be performed to the databases. Like in this example, one single statement can be first, very long, and second, contains keywords that feel familiar but follow a very specific syntax and have specific meanings. To help beginners practice SQL and make the learning task less overwhelming, we use a type of programming problems called micro-Parsons problem to support learning. So what is a micro-Parsons problem and how is it different from previous learning tools for SQL? Parsons problems are a type of programming practices for beginners. Traditional Parsons problems on the left contain a problem description similar to a common write code problem, but instead of asking learners to write code from scratch, it contains correct code blocks in a mixed-up order and asks learners to rearrange them into the correct order. Parsons problems have found to be improve problem-solving efficiency and promote programming pattern acquisition, while they can maintain an equivalent learning gain compared to writing code from scratch. Micro-Parsons problem, in our case, is a variation of Parsons problems, but they focus on a single statement, which is the case for SQL code for beginners. So, how is micro-Parsons problem different from previous learning tools for SQL? Previous work have developed some tools for SQL, but they are focused on different aspects. For example, SQL Repair automatically fixes learners' select statements, and another SQL adaptive learning system by Brivlovsky, they focus on navigating learners to the ideal level of material, so they were creating adaptive difficulty for learners. There are also some block-based programming languages for SQL, like SQL Snap, SQL Helper, and Blockly SQL. Parsons problems are often confused with block-based programming tools. However, there are substantial differences. The main difference between block-based programming tools and Parsons problem is that block-based programming tools are programming languages, which means they are designed to be able to form a large variety of statement or code. However, Parsons problems are only focused on one specific problem, which means that they reduce the problem space. On the other side, block-based programming usually have a very large problem space. For example, SQL Snap has 30 types of blocks while they only support one type of statement, which is select statement. And SQL Helper has 23 types of blocks. The picture on the left shows an example of some of the available blocks provided in SQL Snap. This is an example of micro-Parsons problems in SQL. It starts with a problem statement, which includes any description of the problem, such as screenshots of the table and the problem requirements. It follows with an input area, which provides the learners with a variety of blocks that are part of the solution but in mixed-up order. To answer the questions, learner can drag or click on the blocks to add them into the input area. After they're done, they can click the Check Me button to see the feedback for their answer. To understand how to best help learners, we implemented two types of feedback mechanisms. We implemented both block-based grading on the left side, which means we highlight the incorrect code blocks when students have incorrect answers, and execution-based grading on the right side, which execute the code rearranged by students and showing either error message or execution result. To understand how this tool and the feedback mechanism affect learners, we conducted 2 studies. With the goal of understanding students' subjective perception, we conducted a think-aloud study with within-subjects design to collect qualitative data from students. Then, to understand how the tool will affect learning in the classroom, we conducted a classroom field study, which has a between-subject design and collected quantitative data. Part 1 is a think-aloud study. We recruited 12 undergraduate students from a data-oriented programming class. We included 3 conditions in a think-aloud study. The first condition is micro-Parsons problems with block-based feedback. Second is micro-Parsons problem with execution-based feedback, and traditional text entry questions with execution-based feedback. The 3 conditions are, in short, PB, PE, and TE. For each participant, we first asked them to complete a pre-task survey, which has a self-efficacy questionnaire as well as their prior knowledge. Then we asked them to complete 6 practice questions, and we used a counterbalance design to minimize the ordering effect such that they are exposed to all 3 conditions. Here are the results. Prior to the study, we asked the participants to rank their familiarity with the topic from 1 to 5, with 1 as the lowest and 5 the highest. We found that learners who preferred text entry the most had an average of familiarity of 3.27, but learners who preferred any type of Parsons, PE, or PB had an average of 2.62. After practicing with the tool, we asked learners to rank the 3 conditions in terms of their preference. After that, we asked them what are their criteria for preference. We found that learners' criteria included perceived learning, task authenticity, and prior knowledge. Although students have very different preferences towards some features of the input type and feedback, they identified some of the common features provided by these 2 elements. For the input type, they think that the text entry provides less help, has more details, and provides a typing experience. For micro-Parsons problems, some students consider it as a knowledge input process and think that it requires less details such as typing or typo or spelling. Some of them also fear that they will game the system with micro-Parsons problem. In terms of feedback, students recognize that block-based feedback uses a natural language as prompt and help them locate errors. For execution-based feedback, they think they are more difficult and also more authentic. It is important to note that while learners recognize common features for the input type and feedback, they have very different preferences because of their variation in prior knowledge or values in terms of task authenticity and perceived learning. In the second part, we conducted a classroom study that spans across 2 semesters. These are 2 separate between-subject studies. In the first semester, we compared micro-Parsons problem plus block-based feedback versus text entry problems. In the second semester, we compared micro-Parsons with execution-based feedback versus text entry. These 2 studies were conducted in the same course but had different population. In each experiment, students are randomly assigned to 1 condition. In each semester, we conduct the study in 2 sessions during the 2 consecutive lectures of the course. Take the PB and TE1 study as an example. During the first lecture, the instructor briefly introduced the basic concept of databases and tables, simple select, update, insert, delete statements. At the end of the first course, students took a 10-minute timed pretest with 3 traditional text entry problems. No assignments on databases or SQL were issued between the 2 lectures, so that any learning gained from the pretest to post-test likely resulted from the practice activities in the study. The second part was conducted at the beginning of the second lecture, which happened 2 days after the first lecture. It started with an 8-minute knowledge introduction, including 3 worked examples for select, update, and join. It reviewed the knowledge covered during the first lecture and introduced new knowledge prior to asking learners to practice. Then, we randomly assigned learners to one of the conditions and asked them to practice. Finally, we asked them to complete a 10-minute post-test. These post-tests used isomorphic problems as a pretest. All of our experiment materials are available on ICM Digital Library. We developed a grading rubric and evaluated learning gain and students' abilities to reproduce certain programming patterns. When comparing the pretest data between 2 semesters, we found that the second semester had a significantly higher pretest score than the first semester, suggesting the population for the 2 semesters are not comparable. Thus, we did not perform any comparisons across the semesters. For the comparison between block-based feedback microparsons problem and its control group, we found a significant difference in the overall learning gain. However, we did not find the difference between Parsons with execution-based feedback versus its control group. We also collected data of students learning of 2 code patterns included in the study. In the PBT1 comparison, learners in the PB group demonstrated a significantly higher learning gain for the first pattern compared to TE1, but no significant difference for the second pattern. Interestingly, in the PE-TE2 comparison, learning in the execution-based Parsons group demonstrated a significantly higher learning gain than their control group for the second pattern, but not the first pattern. Detailed discussion about our research questions can be found in our paper. From a design perspective, microparsons are not just a smaller version of Parsons problems. In our interviews, we found that students recognized microparsons problems as an alternative type of input. Microparsons problems can be better used to present a code pattern by including larger code blocks, while it is less common for a traditional Parsons problem to include huge code blocks that includes multiple lines. We also found that authenticity matters for learners, which means that they value the practices that are more similar to the scenarios that are important to them, such as exams, interviews, etc. When we're designing practice tools for learners, we need to help them recognize that they can gradually transition to the authentic task. For example, in microparsons problems, we can use a mixed input modality to adjust the difficulty, ranging from providing all blocks, asking learners to use a mix of blocks in typing, and transition to typing from scratch. Our limitations include volunteer bias for the think-aloud study and selection bias for the classroom study, as not all students came to both lectures. Also, in our study, the participants in 2 semesters are not comparable, so we were not able to compare the 2 different feedback mechanisms in this study. In our future work, we plan to explore the transition to writing code, understand the effect with more advanced SQL problems, and conduct studies to directly compare the effect of different feedback types. Thank you for listening, and please refer to our paper for more details.